Thank you for having me here. I think it's a great event, and this event shows once again that additive manufacturing gets more and more the attention and the interest from the academic world, but also authorities and businesses. So in the next 20 minutes, I'm going to share with you some of the outcomes of the projects, the analyses, and the panel debates that CECIMO conducted recently. So I'm going to share with you some main, oh yeah, I need the pointer. Okay, thanks. Some main challenges and mainly opportunities. But let me start by saying just a few words about CECIMO. So CECIMO is European Association for the Machine Tool Industries. This means the metal working machinery, better known as metal forming, metal cutting, and additive manufacturing. Over the years, we came up with quite some new materials, like also aluminium, titanium, to name a few, and also with quite some new technologies, like cutting, forming, electro-discharge machinery, and other unconventional processes like laser cutting, water jet cutting, electro-beam machining, and ultrasound machining. I'm not going to list now all the technologies that are available in additive manufacturing, as they have been discussed over the last 3 days over here, but I can tell you that CECIMO covers them all. So CECIMO is a specialized advocacy association in Brussels, but we do have 15 national associations in the different member states of the European Union. In some countries, these associations are specifically for 3D printing or additive manufacturing. In others, they are just incorporated in the broader Machine Tool Association or Advanced Manufacturing Association, as they are called in quite some countries. So besides our members, like for example over here in Spain, we have AFM, we have also ADIMAT, with a specific association of 3D printing over here in Spain. So those 50 national associations, they cover not more, but they cover nearly 100% of the total machine tool production in Europe. So it has to be clear that CECIMO represents the European manufacturers, or call it builders, of also hybrid machinery, which is close to our subtractive way of working. But we also cover the European manufacturers of builders of additive machinery. But there we go even further, because in that sector, we do represent all the players in the value chain. It goes from design, materials, the machine producers, software equipment, and services. So, what do we do in practice? CECIMO focuses, as I told you, on defending the interests of the European additive manufacturing players at European level and global level. So we know that quite some new players have entered recently with huge investments, like General Electric, and some others are really emerging due to a lot of state aid, like in China. So this means for us in Europe that we have to do our utmost best in order to keep European additive manufacturing as one of the world leaders. And we also have to make absolutely sure now that this technology becomes more used by the industrial mainstream. Practically, our work is divided into 3 main focus areas. First of all, projects, and I'm proud to say that we work together with some of the best companies and researchers in Europe. And this to tackle issues to the industrialization of additive manufacturing. And these studies, they are both analytical studies, like on the industrial sector, on skills, but also technical studies, really the development of machine concepts. Altogether, these projects have mobilized more than €2 million of EU funding. A second activity is about organizing large conferences and panels with key additive manufacturing leaders in order to raise mainly awareness. You can see them on this slide. And we felt that the link between the government and industry was missing. So that's why we wanted to close this gap by bringing together on the one side the key decision makers and industry on the other side. This brings me to our third initiative, which is about lobbying on EU legislation and priorities. We secured with success recently more funding for AM skills and will continue to do so in the future. We'll also make sure that regulation does not hamper our industry, as not have a negative impact on our industry. We also have recently a specific working group on intellectual property rights. And now I would like to present you 3 main areas on which we have to focus in order to stay competitive in Europe. The first one is about strengthening every chain in the additive manufacturing value chain. Together with many experts across Europe, we took a picture of the actual state of play of the European industry additive manufacturing space. We took a look at the most relevant value chains and at the potential gaps in them. Today it's clear that additive manufacturing machine producers are key innovators in the whole ecosystem, in the total value chain. They are working on the customization of the machines for specific end users. They are automating steps to reduce their need of human involvement. And they are focused on the industrialization of additive manufacturing by providing training and technology applications to large end users from several sectors. And this is a group of mostly European players, where we, on the other hand, as Europeans, where we have less presence in the total value chain is in the field of powder metallurgy. In this segment, we do lack expertise in Europe. And let me turn to a practical example. In this slide, you can see one of the value chains that we recreated in one of our studies. It's about the production of structural parts for the aircraft. Such a structural part is, for example, a plane bracket, which is basically the linking section between wings and engine. Big end users are interested to use additive manufacturing technologies to make these brackets. Just last month, and as well as September 2017, Airbus took a big step forward by installing a titanium bracket made with additive manufacturing on the airframe of a commercial plane. Until then, it only installed those brackets on test planes. What we found in the value chain is that the lack of expertise in the transformation of raw materials for high-class alloys like titanium and aluminium is a clear obstacle in Europe. We need more expertise in understanding the properties and the performance of these materials. We need more efforts and closer attention of European research bodies, including the public ones, to improve our capacities in creating high-class titanium and aluminium powders. This will also allow then the application of additive manufacturing in new areas like those in this slide. And important to say, this should also be achieved by developing our knowledge about recycling raw materials. Well, let me just say that just a few days ago, the first European plant for the transformation of scrap metal into titanium for the aircraft industry was inaugurated in France. The European Investment Bank played an instrumental role with a loan to the project actors. We need these sort of investments to keep up with international competition. This shows that the attention of authorities for powder metallurgy, for additive manufacturing is increasing in Europe. For the next slide, I turned the focus on the process flow. So a second area that gets a lot of attention nowadays is process monitoring. This is especially also by the machine manufacturers. To industrialize additive manufacturing, we need to have well-developed standards and an extensive certification system in place. This is crucial, especially for customized and low-volume components. Good standards will guarantee that the quality of parts created can be repeated. Today, one common way to qualify metal materials is to conduct a lot of tests and to collect a lot of data from these tests. When there are doubts on the performance of a material, many tests are done before the actual production starts to minimize those doubts. But this requires then a lot of money, and it can take up to 15 years in some cases. But there are other ways to do that. There exist, for example, software models that need little testing, or by comparing the performance of new material with already qualified ones. We see that the metal additive manufacturing industry is moving towards those two approaches, but is also pushing towards controlling the production process in real time in order to understand aspects like porosity and discontinuity of material. Getting more data on these aspects will also facilitate the qualification and the certification of the parts. So with these objectives in mind, producers of machines are making efforts to develop models for in situ process monitoring. This works with sensors that provide data that can be analyzed in real time with closed-loop feedback. This way of working is already advanced and applied in subtractive manufacturing, but it is a clear missing element in additive manufacturing. There will be, as I told you, a real race towards comprehensive in situ process monitoring. Here it is possible at this moment to make the difference and to be one step before the competition. The table in this slide gives a picture of what is for the moment available. Models that allow for in situ process monitoring are developed by producers of machines, but also by providers of sensor technology. This is the measurement specialists. Some actors have generated models that monitor specific aspects of the process, but most of the time, data is stored and only analyzed later after fabrication. For sure, things are moving in the right direction, but there is still a long way to go to understand completely the anomalies in the process. However, the more we understand these anomalies, the better we can reinforce the qualification and the certification process for final parts. The third and the final area that I want to speak about today that gets a lot of attention by the industry is the area of skills, and this in the very large sense of this word. First, I would like to talk about technical competences. We all know that designers will be a key occupational profile for the adoption of additive manufacturing in the factory. There is a need to retrain design engineers who are used to work with conventional machines and to make them aware of the increased freedom in design that additive manufacturing allows. This requires them to think in a complete different way about the design of a part. However, besides design skills of engineers, many other skills will be high in demand. For example, as we use metal powders in the production process, there is a higher need for safety standards at the workplace. We predict that specific job profiles with responsibilities in guaranteeing health and safety standards on the shop floor will gradually emerge. These profiles will normally be experienced technicians with at least 3 years of experience with the technology. They will monitor activities like the loading and unloading of build platforms, the storage and handling of metal powders, or the removal of metal powders in excess from the parts that have just been produced. We need to make sure that vocational institutes across Europe offer appropriate training programs focusing on those skills. And here I see the role of industry as key. We should create a culture of closer engagement between companies and vocational institutes in the preparation of relevant curricula. As the technology advances quickly, educators have problems to align their offerings with the expectations of the employers. We need to bring those two worlds better together. Another element in the third area of focus concerns the recognition of skills gained by people in this field. We lack today the formal recognition, or call it qualification, certification, of some additive manufacturing competences. As a result, for example, HR managers find it difficult to understand and to assess, to judge properly the type of abilities, knowledge of a candidate and its level of expertise in the sector. The formal recognition and standardization of skills acquired concerning additive manufacturing technology and/or additive manufacturing industry in general should be a priority. And this should be done at least at a European level. This is also directly linked with the need to guarantee the same quality of skills all over in Europe. These standards at EU level will then also boost the mobility of workers. And in an industry with skills shortages like ours, this opportunity must really be used. The third and final element that I identify in this area of focus is the interpretation of or expectation of what additive manufacturing can change in or for an organization. Some end users are still approaching this technology thinking that it must replace the existing subtractive machines in their factory. This is not the right way to see it. We need to understand that additive manufacturing is complementary to the current processes. To make additive manufacturing mainstream in industry, it must be fully integrated in the current production line of the end user. For this to happen, we need two main actions. First, we need to exploit the emerging Industry 4.0 tools, and we need to see how to increase the exchange of data between subtractive and additive machines in the factory. Second, we need to build more collaborations between producers of subtractive machines and additive players. We need to team up better in Europe to see how additive can fit into the existing production processes. So to conclude, we must recognize that the competition in the market is really increasing. CECIMO is doing its part at EU level to make sure that the development and the growth of additive manufacturing sector is a priority for our public authorities. I identified three main areas of attention by additive players nowadays. These three areas imply barriers for the industrialization of additive manufacturing, and we need to tackle them. First of all, in the value chain, having a more developed metal powder metallurgy segment will be a great benefit for moving additive manufacturing towards series production. More focus on high-class materials like titanium and aluminium is needed. This will then unlock quicker, more technology applications, like in the example of the aircraft structural parts that I showed you before. In terms of production process, in situ modules to capture data and analyze it in real time are key for the adoption of additive manufacturing and to make certification also quicker. I think this is something that will remain a priority for industry players at least for the next 3 to 5 years. Now, in terms of knowledge, I told that we need not only new design skills, but also extra people who are able to ensure that all health and safety standards are kept at the workplace. I have also illustrated that we need a better formal recognition, certification of the competences of people in additive manufacturing, which today is really missing. Finally, a more realistic interpretation of what additive manufacturing can do is needed by industrial end users. Digital tools for machine-to-machine connectivity and more partnerships in the market between actors in subtractive and additive manufacturing are a way forward to advance to that. EU public actors must support all the efforts of our companies in these three critical areas. They must catch up with the increasing research ambitions of other governments across the world, like in China and the USA, and they must provide enough funding for companies also in terms of testing. This must come together with a bigger attention on the evolving skills needs of this sector and the alignment of regulations with the new characteristics of additive machines. I would like to thank you for your attention.